Look closely at this traditional pickle jar. From the outside, it looks like a simple container, but the glass actually protects a self-contained biological vault. If we could travel inside, the raw vegetables would look like massive, towering structures. Clinging to every surface of those structures are thousands of tiny, glowing specks. These specks make up a microbial community, a collection of microscopic living things that share the same physical space. Every vegetable pulled from the earth naturally carries these tiny native cities. This invisible city drives the entire pickling process. The microbes change the vegetables at a cellular level, creating a shelf-stable food through their own biological activity. The environment inside changes when we close the vault. As the heavy lid slams shut, it cuts off outside air, sealing the space in darkness. Trapped inside, these tiny residents begin a process called fermentation. They start breaking down the sugars in the raw food, using them to create the energy they need to stay alive. Removing the oxygen forces the microbes to shift their survival strategy. This change in behavior is the primary spark for the preservation cycle. Without oxygen to breathe, the vault becomes a harsh environment. Most of the common microbes that were living on the vegetables quickly go to sleep or die off, but a specific group of survivors wakes up to take control. They belong to a uniquely tough family known as lactic acid bacteria. You can think of them as a specialized work crew designed to thrive when conditions get difficult. This resilient family acts as the engineering workforce. They are the only ones with the tools needed to rebuild and secure the ecosystem inside the jar. To survive without air, these engineers use a method called anaerobic metabolism. This is a way of eating and creating energy entirely in the dark without requiring a single breath of oxygen. As you can see here, the microbe extracts a carbohydrate molecule and converts it directly into a pulse of energy. To find that energy, the microbes pull sugars leaking out of the massive plant cells into the surrounding liquid. This oxygen-free eating habit is the engine of the vault. It powers the entire biological transformation taking place inside. As the microbes consume those vegetable sugars, they produce a protective byproduct called lactic acid. Imagine this acid as a dense, glowing mist. It vents from the microbial engineers, rolling across the vegetable surface until it fills the vault. The steady production of this mist creates the foundation for the jar's natural defense system. As the mist accumulates, the environment turns sharp and sour. This rising acidity indicates how effectively the mist has saturated the vault. The acid functions as a biological force field. It neutralizes and destroys dangerous spoilage organisms that attempt to grow in the liquid, preventing the food from rotting. Through this process, the microscopic engineers create a chemical barrier that protects the vegetables and keeps them safe for us to eat. To help the engineers, we add a heavy shower of salt. This physical force pulls water directly out of the vegetables to create a brine. The amount of salt in the liquid is the salt concentration, and it acts as a crushing security filter. On the left, you can see a harmful bacterium shrivel and collapse as the salt sucks the water right out of it. But on the right, the armored lactic acid bacteria easily repels the salt and stays perfectly healthy. This salt filter is a targeted weapon. It clears away dangerous pathogens while giving the beneficial armored microbes total control over the environment. Large-scale factories often prioritize speed and infinite shelf life over this delicate internal balance. In many mass production facilities, vegetables are submerged in excess salt and treated with high heat. While this ensures the jars can sit on a shelf for years, it creates enough cellular stress to kill the microbes. This chart shows the result. The bottom half is a biological collapse, where the ecosystem is red, stagnant, and completely inactive. Natural preservation is different. It keeps the food stable while maintaining its biological activity. The vegetables stay safe, but the ecosystem remains vibrant and alive. Oversalting and high heat turn a living ecosystem into a processed snack. Without those active microbes, the final product offers no probiotic benefits. When we open a properly balanced traditional jar, we find vegetables saturated with millions of victorious living defenders. These survivors are called probiotics. They are tough enough to travel through the stomach and into our gut, where they assist with our digestion. Once inside the body, they go to work. They trap dietary cholesterol to help keep it out of the bloodstream, and they release chemical weapons that seek out and destroy invasive diseases. By eating traditional pickles, you bring this active workforce into your own system. These microbes assist your natural defenses, acting as a protective guard force for your own internal vault.